Okay, today we are going to start Module 3, Lesson 4, and Lesson 5. And we're just going to hit the main points of them for the video today in a shortened version. And then later, if you would like to get the rest of the notes, you can come and get them. So, this is kind of a review of what we've been talking about here, only we're going to put a name to it today. So we're going to talk about the fundamental theorem of similarity. And basically, it's just putting a name to everything we've been doing thus far. So right here, this diagram, you have center O, says dilated by a scale factor of 3 right here. And here's what we have. It says if the length of OR is 2.3 centimeters, what is the length of OR prime? So basically, if we know from here to here is 2.3 centimeters, and our scale factor is 3, to find OR prime, we just do 2.3 times our scale factor of 3, and we get 6.9 centimeters. Okay, so that's this longer length. Similarly, if OS right here, if this is 3.5 centimeters, to find OS prime then, we would, again, multiply it by the scale factor. So 3.5 times 3 is equal to 10.5 centimeters. Okay, so these are all by a scale factor of 3. Now, in the next page, I'm just going to summarize it here while we're looking at it. It asks you some more questions about this, and one of them is what happens then when you connect R to S and R prime to S prime? Well, if we connect these using a straight edge, and it actually asks you to measure them on the next page, but for the sake of time here, we're just going to talk about them. What is the relationship then between this length, R prime, S prime, and RS? Well, since the scale factor is 3, if we measure these out, this one, R prime, S prime, should be 3 times the length of this guy right here. And that's what our fundamental theorem of similarity will show. The other thing that the following questions refer to are the angle measures. So, for example, if you are told here, you have two triangles here. You have this little triangle, ORS, and then you have a bigger triangle, OR prime, S prime. If I told you in the beginning that this angle right here was 30 degrees, what that tells you is since we dilated everything by a scale factor of 3, this triangle right here, it doesn't dilate that. It keeps it the same. This would also then be 30 degrees. Angle measure is preserved here using FTS. And that's for all the angles. If I told you R was 60 degrees, then R prime here, this angle would also be 60 degrees. And that's the gist of the FTS. And that's pretty much lesson 4. That's what we're going to go over for the video. Lesson 5 takes this a step further. And so we're going to skip now to lesson 5, which is on page 21. And this is referring now to the consequences of the fundamental theorem of similarity. So this picture should look a little familiar from lesson 3, which we did last week. And first and foremost, if you have this picture and it's all labeled PQ is 5, P prime, Q prime is 10, determine the scale factor. Right away, you know that this is the image, so 10, and if you divide that by our original, 5, you'll get your scale factor. So our scale factor here is 2, and we have already learned that. But what we haven't done is find the center point by which it's dilated. So these two are parallel. We have our scale factor of 2. And the way you would do that is you line up your two P and P prime, and you draw a straight line through that. And then if you line up Q and Q prime, and draw a straight line through that, you get your center point, which we call O because that's the origin or where that originates. And there is your center point. And it says down here to measure the segments to verify that this is all within the same scale factor, which we're again not going to do. But what you'll find is that this length right here is going to be double this length right here. So this will be 2 times the size, which hence our scale factor of 2 here. Same over here. This bigger length is going to be 2 times the size of OQ. All right. On the next page then, we're just throwing this on the coordinate grid. But again, we are reviewing this, which is why I'm going through it so quickly today. With our project, we did the same thing here. We did a lot of this, but on the coordinate grid, if you're given a center point here at the origin and a point A, so this point is at 3, 3, it says our scale factor, let's dilate by a scale factor of 4 and find A prime. Well, what you do then is you multiply both of these by 4. So if you multiply 3 by 4, our new first coordinate, our new x is going to be 12. And if you multiply this 3 by 4, your new x or y is going to be 12 as well. So A prime is going to be 12, 12. So over 12, up 12. And again, you should land on this line. Here's your A prime. And again, that is a review. Now, where we're starting something a little bit new, where we're going to extend our knowledge today, is the next page. And what's new about this next page, page 23, if you read it, in the diagram below, you are given center O and ray OA. Point A is dilated by a scale factor R equals 5/12. And so that's where our new thing is. We have not actually been dilating by a fraction. So that's going to be a new situation. And you're going to do everything the same way, though. Use what you know about FTS to find the location of A prime. Well, A is way out here at the point 12, 8 now. And you're going to do the same thing. To get your new point A prime, you're going to multiply each coordinate by 5/12. And what will happen, since this is a fraction now, instead of making this length longer and pushing A out, it's going to shrink back in, and A prime is going to become closer to O. So 12 times 5/8, and for those of you that don't remember, 5/8 is the same as 5 divided by 8. If you do that, 12 times 5/8, you're going to get 5. So that's our new x coordinate. And then if you do 8 times 5/8, you get 3 1/3. For those of you that like decimals better, that would be 3.3 repeating. And that's our coordinates for A prime. And now we want to put that on the graph. So we're going to go right 5 and up 3 1/3. And it should land right on the line. That does look like 3 1/3 right there. So there's A prime. And that is the gist of our lesson for today. I know we skipped a lot for the video, so if you want to get the extra notes, you may. The homework today is going to be starting on the next page, page 24, where it says problem set here, and we're going to do numbers 1 through 3. So page 24 and 25, numbers 1 through 3. Okay, if you need anything else, please come and see me either before school or at lunch.